Welcome to this session on CCNA tutorial, Network Fundamentals. This video is aligned with Cisco's official CCNA 200-301 exam blueprint and is designed to guide you step-by-step towards certification success. In this lesson, we cover Section 1.9 IPv6 Address Types. We'll explore how IPv6 handles communication between devices, using unicast, multicast, and anycast addressing. You'll also see how IPv6 replaces broadcast, how devices discover routers, and how EUI64 automatically builds interface IDs. By the end, you'll clearly understand how IPv6 sends data one-to-one, one-to-many, and one-to-nearest. IPv6 groups addresses into three main types: unicast, multicast, and anycast. Unicast sends packets one-to-one, from a single source to a single destination. Multicast sends one-to-many. Every device that joins that multicast group receives the packet. Anycast sends one-to-nearest. The same address can exist on several devices, but only the closest one replies. IPv6 doesn't use broadcast at all. Multicast and anycast replace that function, making the network more efficient. A unicast address identifies a single interface. Packets go straight from one device to another, just like normal host communication between clients or routers. Each unicast address is unique across the network. For example, 2001 DB8 ACAD1:10 delivers only to that one host. These are what you'll use for regular end-to-end communication. Multicast identifies a group of interfaces, usually across multiple devices. It's a one-to-many delivery method. IPv6 uses multicast instead of broadcast for things like neighbor discovery, routing updates, or video streaming. For example, FF02:1 targets all IPv6 nodes on the local link, and FF02:2 reaches all routers on the local link. Anycast addresses are assigned to several interfaces, often on different devices, but only the nearest one responds. It's a one-to-nearest delivery, great for load balancing or redundant services like DNS or web servers. A DNS anycast address, for instance, will always connect you to the closest available DNS server. Again, IPv6 doesn't broadcast. Multicast and anycast handle that role. IPv6 supports several address types, each with a specific purpose. Global unicast starts with 2000 and has a /3 prefix, is publicly routable. Unique local starts with FC and uses a /7 prefix. It's private and used inside organizations. Multicast starts with FF and uses a /8 prefix. It's for one-to-many communication. Link local starts with FE and has a /10 prefix. It's auto-assigned for local communication. Anycast shares one address across multiple devices, delivering packets to the nearest one. Loopback :1 is for internal testing, and unspecified is used before a device has an address. Unlike IPv4, an IPv6 interface can have multiple addresses at once. Each interface always has one link local address, automatically created, one or more global or unique local addresses for external communication, and several multicast memberships for discovery and routing. This design gives IPv6 flexibility. A single interface can talk to local devices, the internet, and multicast groups all at the same time. Modified EUI64 is a method that lets a device build its own interface ID automatically from its MAC address. It works by splitting the 48-bit MAC in half, inserting FFF and an E in the middle, and flipping the 7th bit of the first byte. This method ensures every interface ID is unique while keeping the address predictable. It's widely used for automatic configuration through Slack or manual prefixes with the EUI-64 keyword. Here's how we convert a 48-bit MAC address into a 64-bit interface ID using modified EUI-64. Step 1. Split the MAC into two halves. The first half is 001A2B, and a second one is 3C4D5E. Step 2. Insert triple F and an E in the middle. That gives you 001A2B triple FE 3C4D 5E. Step 3. Flip the 7th bit of the first byte. The original first byte is 00, which in binary is all zeros. Flipping the 7th bit turns it into 02, so the final interface ID becomes 021A2B triple FE 3C4D 5E. Routers periodically send router advertisement messages to the multicast address FF02:1, which means all nodes. The RA includes the network prefix, prefix lifetime, auto configuration flags, and the default gateway. Remember, in IPv6, the default gateway is always learned through RA, not through DHCP. These messages tell hosts whether to use Slack, stateless DHCP-v6, or stateful DHCP-v6 to configure themselves. When a host first joins the network, it doesn't want to wait for the next periodic advertisement, so it sends a router solicitation to FF02:2, the all routers multicast address. This asks routers to reply immediately with an RA message, so the host can configure its IPv6 address right away. Usually, a host sends a few RS messages at startup. Neighbor Discovery Protocol, or NDP, replaces ARP in IPv4. It uses ICMP version 6 messages for discovering other devices, learning MAC addresses, detecting duplicates, and finding default gateways automatically. NDP uses messages such as neighbor solicitation, neighbor advertisement, router solicitation, and router advertisement. All of this happens through multicast instead of broadcast, making IPv6 communication much more efficient. Let's recap. IPv6 uses unicast, multicast, and anycast instead of broadcast. Every interface always has a link local address and usually one or more global or unique local addresses. The modified EUI64 process builds a 64-bit interface ID from the MAC address. Router solicitation and router advertisement work together to automate IPv6 addressing, and neighbor discovery for device and gateway detection. In short, IPv6 is simpler, smarter, and built for the scale of modern networks. Before moving on, take a quiz to test your understanding. Quizzes, summaries, and slides are available on ccna.academy. If you have any questions, leave a comment below and I'll be happy to help. Up next, Section 1.10. Verifying IP parameters on different operating systems. We'll see how to check IPv4 and IPv6 configuration details on Windows, macOS, and Linux.